Thank you very much. So my task was to talk about climate change more generally, and I probably should have been on before the last two speakers in many respects, but I also have to relate it to the state of Colorado. And the opening slide here suggests that there's a whole lot of manifestations, different manifestations of the way in which climate change occurs, and I'm going to talk to you a little bit about some of those, because often they're not associated with climate change, and yet they really are. So to begin with, if the planet were to go to the doctor and it has certain symptoms, the symptoms are that the temperature is rising, it's running a fever, and also the composition of the atmosphere is changing, the carbon dioxide is increasing. So the diagnosis is that these two things are actually related to one another, and that the human activities are causal. The prognosis then is for more warming at rates which can be quite disruptive and will have profound effects on many organisms and ecosystems and society. And the treatment, these have special words, are mitigation, which refers to reducing emissions of carbon dioxide into the atmosphere, and adaptation, which is planning for the consequences, and we're really not doing enough of either of those two things. Now, we have many facts. We have a lot of evidence. This is one of the things about science. We have a lot of physical understanding. Patrick Daniel Moynihan said, "You're entitled to your own opinion, but not your own facts." And yet there's a lot of opinions out there which are based upon absolute rubbish. But the facts are not enough. And so as scientists, our role is to lay out the facts and what the prospects and the consequences are, but the decision on what to do about it is up to everyone. And it's also very much in the hands of the politicians, unfortunately. But climate change is happening. There's no doubt about it. It's due to humans. 97% of scientists actually agree. There's a very small percentage which don't for one reason or another. The data are certainly of mixed quality and length, and Mark has talked to you about some of them in the Arctic, but together they all tell a very compelling story, and they leave no doubt about the role of humans on the climate change which is going on, none whatsoever. But what we do about it does depend upon our value systems in addition to the evidence that we have compiled. So what's causing the warming? We are. And this is one of the manifestations of that. If we look at the energy supply, you'll see that the increases in energy that we have produced and the sources of that is dominated entirely by fossil fuels. And many people are quite surprised by how rapid the increase has been after about the 1950s, after about 1960. It's mainly in the last 50 years that this has really become a major problem. And what we've done in the last 50 years has greatly exceeded anything that went before then. The consequence is increases in carbon dioxide. This is the carbon dioxide record from Mauna Loa, established by Dave Keeling, a good friend of mine, in 1958. And it has a sawtooth character to it, which is the breathing in and out of the planet, so to speak, as there's a drawdown of carbon dioxide in the atmosphere in the northern hemisphere summertime, spring and summertime, with photosynthesis as the northern hemisphere greens up. And then in the fall and in the winter, when the leaves are on the forest floor and are decaying and so on, this carbon dioxide that goes back into the atmosphere. And that's the annual cycle, the sawtooth character that you see to it. And that's actually huge. But it's dwarfed by the changes that are occurring over time. And let me point out one of the key characteristics of this is that when this was first measured, it was increasing at this rate, and then the rate has systematically increased over time. This is going in the wrong direction. The Kyoto Protocol was established in order to get this to turn down and go in the other direction, and it hasn't happened. And in recent times, it's because of industrialization and increases of standard of living in places like China in particular, and India, and other parts of the world. And so this is a major problem. We're not headed in the right direction in regard to this. And there's no doubt whatsoever that this is due to human activities. And so Mark described this briefly. We have the incoming solar radiation. Some of it gets reflected from clouds. Some of it gets reflected from the surface, a bit more in the Arctic because it's bright. About 30% overall gets reflected. The other 70% gets absorbed in the system. And to have an equilibrium climate, the planet radiates. Here in Colorado, we experience that at night. As soon as the sun sets, it gets cool. That's because we don't have much water vapor above us. But on a cloudy night, it acts as a blanket, and it doesn't cool off as much. And so that's the greenhouse effect from clouds and from the greenhouse gases in the atmosphere. Water vapor is the dominant greenhouse gas in the atmosphere, but it's relatively shallow. Water vapor, however, has a very short lifetime, about 9 days on average, a water vapor molecule, whereas carbon dioxide lasts for centuries. And so the increasing carbon dioxide in the atmosphere is providing a blanket that's warming the planet. And so we have an energy imbalance because there's increased trapping of this energy that would normally be escaping to space. And we can actually measure that in different ways. It's not easy, but what happens is that extra heat, where does it go? Some of it goes into warming the land and the atmosphere. And so that relates to temperatures, which I'll show you. A lot of it goes into heat storage in the ocean, and then the ocean is expanding, and therefore sea level is going up. Some of it goes into melting land ice. Mark showed you some of that in Greenland and other glaciers on land, and that puts more water into the ocean, and so that raises sea level. Rising sea level then is a very strong symptom of increases in this problem and the increases in greenhouse gases. Some of it melts sea ice, the Arctic sea ice, and then the water has to be brought up to ambient temperature, and Mark talked a lot about that. The main complication relates to the last point here, which relates to the water cycle. Some of it goes into evaporating moisture, which then affects rainstorms and clouds, and a lot of my research has been in that, and I'm going to talk a bit about that in more detail because this is very important for Colorado. And some of it then can change the brightness of the planet by changing the number of clouds. And so that has, this is where all the complications occur in number 5. So most of the heat, though, about 93% of it, ends up in the ocean, and that's the memory of where all of these changes have occurred. So this is the actual temperature record. This is the NOAA temperature record dating from about 1880 on. And it has some ups and downs attached to it. The 0 line on here refers to the value for the 20th century. And so there's some zigs and zags. Some of these relate to things like El Nino events. And then this is the carbon dioxide record. Here I've taken the annual averages. These are annual averages of temperatures as well. And I've plotted it in a way to suggest that there's a relationship between these two curves because we think at NCAR that we can prove that there is such a relationship, but we have to use climate models to do that. The scale on the right-hand side you can see over there. And so we have, let's see if this works, yes. So pre-industrial levels of carbon dioxide were about 280 parts per million by volume, and now we're at 400 parts per million by volume. So there's been a 40% increase in carbon dioxide in the atmosphere. That's considerable. You can see that on this record, maybe, that 2014 is the warmest year on record. Boom. That's where we're headed in 2015. September has just come in today, and it's the warmest September on record by far. And at the moment, in fact, that star may well be too low. In fact, this record here, this is now just a part of the record starting in 1920. What I've done here is to plot seasonal values rather than annual values, so 3 monthly values. And here you can see the last 2 seasons on here showing up much above anything else that's occurred. And as I say, September has just come in and is even every bit as high. And so the warming is occurring, but you can see zigs and zags in this, and this relates to especially the role of the ocean in climate. One of the things which is contributing to the warmth this year in particular, this is actually a map of the sea surface temperature anomalies, the departures from normal in the past month. You can see it's right up to date, up till the 10th of October, and it's very warm, especially in the tropical Pacific. And this refers to an El Nino event, very warm conditions in the tropical Pacific, but it's also warm in many other places in the tropical Atlantic, which normally would cause a lot of activity in terms of hurricanes, but all of the action instead is out in the Pacific, which dominates the Atlantic, and so there's a relatively weak hurricane season there, and it's also quite warm in the Indian Ocean and up here in the North Pacific. And so this is going to have consequences for this coming winter, and this is what we expect to happen, that there will be a big shift in where the normal action, main action occurs, out into the central Pacific. It pulls the jet stream down, brings it into California and across the southern parts of the United States. So it's much wetter from California and Texas into Florida and maybe the southern parts of Colorado, but drier and warmer in the northern parts. And so this is the forecast for this coming year, but it could bring tremendous amounts of rain and flooding and coastal erosion in California, especially because the sea temperatures off the coast are so warm. So anyway, you can ask more about that. I don't have time to go into that now. What I thought I would talk about, things that are very important for Colorado, is water. And so what happens when we have extra heat? Well, the human body, how does the human body keep its temperature at the level which it's at? The main way we do it is through perspiration and the evaporation of the sweat from our bodies. And if you go for a hike up in the mountains and you don't have a water bottle, you can be hit with heat stroke fairly readily. And so water is extremely important. We can also use water through evaporative coolers to keep our homes cooler. And in fact, this works very well for the planet Earth because 70% of the planet Earth is ocean. And so the heat actually goes into evaporating moisture from the ocean, which drives the water cycle, the hydrological cycle, rather than heating up the ocean and heating up the planet. And so water is the air conditioner of the planet in that regard, as long as you've got moisture available. And of course, the times when you don't are in deserts or in major droughts, and they've been experiencing that in California. Another example, what happens if we've had rain and there's been a shower, the ground is wet, the first thing that happens when the sun comes out is that the puddles dry up, and then the temperature goes up. But the presence of the water helps to control things, and of course you can do this yourself. If you have a hose, you can spray the side of your house or the car and it'll cool off temporarily, so water can keep things cool. And so, why does it rain? This is one of the questions that we can then begin to ask about what the effects of climate change may be on rain. And so one of the things which you might remember, if you take nothing else away from this tonight, you might remember this number, that the warmer air holds more moisture at 4% per degree Fahrenheit. This is why we use a hairdryer with warm air to dry our hair, because it takes the moisture out much more readily. And so this applies as long as there's moisture available. And so over the oceans, where it's warmed up by a degree Fahrenheit since about 1970, there's about 5% more moisture in the atmosphere all over the oceans on average now, relative to 1970. And so this has consequences. So what happens? We have, say, a parcel of air, and this is my fancy graphics here, all right? You've got to applaud this. This is my cloud down here, a parcel of air. It rises for some reason or another, maybe because the winds are blowing up against the mountain and it goes up, or because there's a cold front coming through or a warm front. There's combinations of air which cause the air to rise in some way, or the ground is being heated. And so as the air rises, it expands, it moves into lower pressure, and it expands, and therefore it cools. that's what happens. Whoops. Let me go back here. This thing doesn't work with these kinds of animations, so we'll try this. Here we go. Here it is, going up, and boom, suddenly you saw the lightning flash. We'll wait for it again. Boom! There we are. This is my animation, you see. And it rains like hell. All right. So that's what happens. So we have this 4% per degree Fahrenheit. And so with global warming, there's more heat that has to go somewhere, and quite a lot of it's going into evaporating moisture. That means in places where it's already dry, things dry out even more. That's the way to think of it. And so that exacerbates droughts. But in places where it's not, where it's raining, the storms reach out and gather even more moisture, and so it rains harder. And so you have, in places where it's raining, heavier rains, and in places where it's dry, the droughts are more intense. And so this is the schematic. This is a big thunderstorm in this case. And what the storm is doing through its circulation is reaching out to grab the available moisture in the environment and bring it into the storm. This time the animation worked. And if there's more moisture lurking around in the environment, then it rains harder. And we've got very good evidence across the United States and in Colorado. Think of the floods 2 years ago, right? That when it rains harder. If you're out on a golf course, by the way, in the summertime, and you feel gusty winds, and then you look around, there's nothing going on locally, but you look in the distance, and you can see a thunderstorm over there somewhere, and that's wind that you feel is actually that thunderstorm reaching out to grab the available moisture at low levels and bring it into the storm so that it can rain. So this is the actual record for the United States. This is the 48 contiguous states. This is the temperature record, and this is the precipitation record. And so here's 51, 52, 53, and so temperatures have gone up 1.5, 2 degrees Fahrenheit, something like that overall. But it's, there's some wiggles up and down in here. The precipitation has a bit more zagged character to it, but it's also gone up somewhat. Let me point out a few things. This is back in the 1930s. This is the so-called Dust Bowl era, where it was very hot and very hot and very dry. And in fact, these two things go together, especially in the summer half of the year. Hot and dry go together, or if it's cloudy and cool and wet, then the temperatures are lower. Now, the way I would characterize the precipitation is by this jump, somewhere around in the 1970s to 1980s. This varies a little bit depending on which season you're looking at. And since the 1970s or thereabouts, there's been about a 7% increase in precipitation across the US. And all of that has occurred east of the Rockies. It includes Colorado. And so there is now more moisture, more rain that occurs east of the Rockies now than there used to be. In fact, many places have gotten used to this, and if they went back to this climate here, there would be water shortages in many places, because many places don't look after the water as well as we do in the West in general, and there's different rules that you may be aware of. This is related to senior rights and junior rights of water and things like that, which I don't, I'll talk about it a little bit more in just a minute. So another thing, let me do it this way here. Another thing is 2012 is by far the warmest year on record. And so this is one of the things which is a bit worrying about the EPA Clean Power Plan is that it was based on 2012. 2012, by far the warmest year on record in the United States, and it was also a major drought. But that drought still was nowhere near as low as many of the droughts earlier in the century. This is the record for Colorado. And again, you see that there's been a substantial increase in temperature at the top. If anything, there's been a slight decrease in precipitation overall. And I want to point out a few things here. In particular, back in the early part of the century, here we are here. Back in the early part of the century, it was very cold and wet. Now, those two things actually went together, as I suggested before, especially in the summertime. But this, it turns out, was a very critical time. This is 1905 to 1928. And then this is the Dust Bowl era. It had some effects in Colorado, but not perhaps as much as a little farther to the east. And here's the 2012 conditions, also in Colorado, showing up that were reflected in the national averages. One of the things that happened that's very important in Colorado is that there was this Colorado River Compact of 1922, which spells out all of the water rights and who owns the water and how much we have to give to the other states further downstream from the Colorado River. And this is responsible. There are thousands, I'm tempted to say tens of thousands of lawyers who deal with water rights. And this is the time when it occurred. It's based upon this period here when it was much wetter than any time in more recent times. And this is why the water is overprescribed. And there are always water shortages, and people are always clamoring for their share of water. And it's actually, from my standpoint, from a climatological standpoint, an awful mess. These are 5-year averages now of the temperatures rather than individual annual values. But this is a key part of some of the issues relating to climate change in Colorado. Earlier this year, Senator James Inhofe went on the Senate floor with a snowball and suggested that, where's global warming? Look at all of the snow that we've got. I mean, you know here in Colorado, when does it snow the most? It doesn't snow the most in January when it's cold. It snows the most in March or November at the beginning and the end of the season. And so when you have storms, and of course, Boston was the one that was the headline, and so this is a big storm that affected Boston with huge snowfalls at this particular time. And so snowfalls if the temperature is below about 35 degrees Fahrenheit at the surface, because the air above the surface is cooler than that. The greatest amounts occur when the temperatures are around, just below freezing. You've probably heard this expression that it's too cold to snow, or you can freeze dry the air. And in fact, if it gets too cold, the atmosphere can't hold enough moisture because of this relationship I talked about, 4% per degree Fahrenheit. The air actually gets freeze-dried. And so cold does not mean more snow. It actually means less snow, or even this very light, fluffy diamond dust kind of snow. So more snow is actually the result of a warming climate unless it gets so warm that it turns to rain. So we expect actually that we could get more snow in midwinter and a shorter snow season at the beginning and the end. And this is actually what we're seeing. And the snowmelt then occurs earlier, which means there's less water lying around in the late spring and in the summertime. And so this makes us more prone to droughts and heat waves and wildfires in the summer. So there's less snowpack by late spring. And this is what's actually happened around the northern hemisphere. This is the actual snow cover extent. And so you can see there's been an increase in October, November, December, and January. And probably if we included last February, because remember last February here, we got a whole lot of snow here across North America. Probably this might be slightly positive. But the rest of the year, March, April, May, June, July, August, huge decreases in the snow cover across the northern hemisphere. And that relates also to what Mark was talking about in the Arctic. So this is where the rubber really meets the road. It's not the gradual increases in temperature that matter. It's these changes in the water cycle that really matter, changes in the extremes that matter. And so with a warming climate, we expect more high temperatures and heat waves, wildfires and other consequences, but fewer cold extremes on the whole. We expect more intense precipitation because there's more moisture in the atmosphere. And we expect that there's going to be longer dry spells, which means there's an increased risk of both flooding and drought, not of course at the same time in the same place, but different places. And we've seen a lot more of that. And it confuses the general public because on average, They cancel out, do they? No. Also, more intense storms, hurricanes, and tornadoes. And so this is a major challenge for water managers. This is a big issue for Colorado. How do you save the extra water for the times when you've got too much, you've got flooding, from the times when you don't have enough? So some recent extremes, just talk about it. This is what it actually looked like in 2012 across the country. Now, surprisingly, in the Pacific Northwest, there was one small area where the temperatures were below normal that year. And in Colorado, it was the first half of the year, you may recall, in 2012, that was exceptionally warm. And later on, it developed more in the center of the country and became very, very warm across the country, with about $75 billion in losses in terms of crops and wheat in particular, and corn and soybeans. So all kinds of records were broken. And one of the consequences was this, you may recall, the Waldo Canyon fire. This is down near Colorado Springs. 346 homes were lost. And this is the High Park fire was up near Fort Collins, 259 houses lost. This was a picture above NCAR. I'm from Boulder, Colorado. And let me do the animation here. Let's see. Boom, there's NCAR there. And so there was a wildfire about a mile away, slightly west of Colorado, but it shut down NCAR for a couple of days because the air quality was so bad you couldn't run the air conditioning and the computers and so on. And later on, in 2012, this happened, Superstorm Sandy. It was a huge storm and about $75 billion in damages. And we can now show that the storm was bigger and more intense and had much heavier rainfalls because of the high sea surface temperatures along the coast, which have a climate change component to it. And I estimate that there was about $40 billion in losses because of climate change associated with this, because of the higher sea levels and the fact that without the more intense storm, the subway tunnels and so on would not have been flooded. These are just summaries of some other things around the world that have a climate change component. Major bushfires and heat in Australia, in Colorado, we saw that already. California was beginning with the wildfires and heat, the drought that was occurring. This is the western US. This is the increases in wildfires that have occurred. This is nowhere near up to date, and this year could well be the worst on record. And then this is the flooding side of things. 2013, major flooding in Buenos Aires, in Germany, along the Elbe River, in Calgary to the north of us, in the northern Rockies. This was before the flooding in Boulder, which occurred in September. In June, they had major flooding up in that region. And in India in June as well. And this is the overall trends in heavy precipitation for the US. And you can see the big increases that have occurred. There's very good data on this. This is very clear, and it's directly related to climate change. In November, we had the big super typhoon that went into the Philippines that also no doubt had a climate change component to it, being bigger and more intense with stronger winds and higher sea levels. Then in 2014, on the flooding side of things, there was major flooding. You may recall all of the stories about the flooding in southern England. Christchurch, New Zealand, had major flooding in March, April. This is my hometown, actually. And in the Midwest in April, again, major flooding. The Balkans in May, again, major flooding. India and Pakistan in September. This was perhaps the more minor of these particular events. But all of these are the sorts of things that are going on. 2015, there was the super hurricane. I think that's a hurricane in the southern hemisphere that went through Vanuatu and caused a tremendous amount of damage. And then there was the flooding in Texas and Oklahoma in May of this year. And of course, this was also extraordinarily wet here in Colorado, but nowhere near as bad as it was in Texas and Oklahoma. And there's big consequences of that. And it was actually linked to very warm conditions up in Alaska. And I happen to think that most of what goes on in the Arctic comes from elsewhere rather than the Arctic being a cause of it. There was widespread disruption this summer. There's been all kinds of records that have been broken. Can you imagine in Europe, temperatures about 100 degrees for a period of time? In Iran, and 215. Japan had the longest period in Tokyo, over 95 degrees. In India and Pakistan, there were 2,300 dead in May and June because of the extraordinarily high temperatures. This was somewhat before the monsoon set in. And then in Canada and Alaska and the California wildfires, and then there's been very active typhoons throughout the Pacific. And so this is California, the wildfires galore at different stages here. In Alaska and Canada earlier, and more recently, especially moving down into California with tremendous costs. And then these are the hurricanes, very unusual. This is out, there's Hawaii. This is out in the Pacific, 1, 2, 3, and this one here, Kilo, actually started off as a hurricane, and then it crossed the date line, and it became a typhoon, because they changed the name. And this was in Japan. This is just north of Tokyo, where there was tremendous flooding in association with this tropical storm, Itao, not very long ago. So all of these events are occurring, and of course, not very long ago also in South Carolina, they had 20 inches of rain in many places with tremendous amounts of rain, moisture coming into that region. As I said, over the oceans, there's a lot more moisture lurking around, and then it gets gathered by a couple of storms and concentrated together, a little bit like what happened here in Colorado a couple of years ago, and the next thing you know, you've got major disasters occurring. And we're seeing more and more of these kind of things. So that's the end of the science at this point. I want to talk a little bit about the societal implications of this. And the science knowledge is going in one direction. We're more and more confident that we've got a real problem and that it's going to have consequences. And there are certain people in the administration that are very much aware of this, and President Obama and the President's science advisor who are trying to do something about this. But the Congress has been a major problem. And so the scientists agree, and yet the majority of the Republican caucus in both the House and in the Senate deny the reality of climate change. And is it a coincidence that more than 160 of those people have received more than $60 million in funding per year from the fossil fuel industry? I don't think so. And so Jürgen Randers wrote an article which suggested that it's profitable to let the world go to hell. So if we left it up to the private sector, this is what would happen. You can read my cartoon there. And in fact, Exxon has recently been discovered as being quite fraudulent in all of this. And so there was a report last year, 2014, put together by not scientists, but by politicians, Henry Paulson and Michael Bloomberg, called Risky Business. And you can look it up on the riskybusiness.org website. And so Henry Paulson said, if we act now, the US can still avoid most of the worst impacts and significantly reduce the odds of costly climate outcomes, but only if we start changing our business and public policy practices today. He also said taking a cautious approach of doing nothing is actually extreme risk-taking, and I agree with him. Bloomberg said the longer we wait to adapt and mitigate climate change, the more devastating the economic impacts will be. And for example, especially on the eastern seaboard, and since he was the mayor of New York City a few years ago, he's very much aware of what happened with Superstorm Sandy. Sea level rise is a big issue on the East Coast. And so by 2050 or thereabouts, we could lose $100 billion of property because it'll be below sea level. Recently, we had a visit from the Pope, and he put out a little bit earlier than that his encyclical, Laudato Si, which is Praise Be to You. And essentially, he's taking a more of an ethical approach to climate change and saying that we need to look after our planet. And so these are some of the things that are in that encyclical, that climate change is a global problem with grave implications, environmental, social, economic, political, and for the distribution of goods, it represents one of the principal challenges facing humanity in our day. He had a critique of consumerism and irresponsible development. He had a plea for swift and unified global action, and suggested that the most vulnerable are the poorest peoples. And other people that read this made comments that concluded that the encyclical was very critical of those who deny climate change, and made statements like, to love God, you have to love and care for the rest of creation. And so this is really a call to action, but it's also a statement that all is not lost. So there are many things you can do. You can use more efficient light bulbs. You can walk and ride a bicycle, drive less, drive fuel-efficient cars. Don't overheat in the summer, in the winter. Don't overcool in the summer. Wear a sweater. Insulate your house. Maybe use biofuels. Use a clothesline. That's how you can use solar power. I've got PV panels on the roof of my house. And there are a lot of other things that you can do. I'm going to stop there, though. We heard in the first talk tonight about the Clean Power Plan. It's something which I think, given that it's a regulatory plan, actually came out remarkably well. I was amazed that the EPA had done as well as they seem to have done in that plan. It's not what is really needed, in my view. I think we need to have a price on carbon. I don't know that we'll get that out of the meeting, which is occurring in December in Paris this year, the so-called COP21, the Conference of the Parties number 21. But if we had a price on carbon, that would change the economics of fossil fuels versus renewables, and it would, I think, bring in the private sector, and you might find some amazing things happening. Maybe we would get more events like the building of a Tesla motor car. With that thought, I will stop. Thank you.